This from your laptop, right?
It's gonna have to come from the laptop. Hello, everybody.
There's a little bit.
I think it's clipping a bit. We can start, I think. Should we start? Are there people in this?
Uh, so, hello everybody. How are you doing? So, welcome today to our first robotic event of this semester for the robotic department. Today we're gonna do a seminar for the Robotrees recap. So, who here attended the previous semester's Robotrees? So, we have 4 people who attended the Robotrees last semester. So, for those who didn't attend it, so let me show you what the guys had to do. Honestly, it was a very big feat, not gonna lie. So this was the map that the guys had to do. So for this map, they had to first the robot had to start here. You can see the mouse, right? The robot had to start here, where right here there would have been a paper or like a color, a certain color, either red, green, or blue. First of all, it had to read this color, then keep following the line till it got to this part, where there would have been an obstacle either here, here, or here. It would have also had to read the distance from the obstacle, and then it had to decide based on the color it read here, whether it had to go left, forward, or right, and then based on the distance, they had to stop either here, here, or here. So, not gonna lie, it was a very hard task, and a lot of people had difficulty with it, since it would have been, for a lot of people, it was like their first experience dealing with this kind of stuff, dealing with robotics, dealing with Arduinos, dealing with wiring, which a lot of people had trouble with wiring, honestly. So this seminar, the whole reason we're doing this seminar was to just do a bit of step-by-step on how you would approach a problem like this, how you would, what is the necessary step that you should try to follow to do one of those objectives. So right now we'll only focus on the line following part because of the time we have. So we'll try to go step by step. How can you do line following using this robot? So these are the robots that the guys had. If you want, we can distribute some of them. Perhaps we can distribute some of them for you guys, so you can see a bit. So these were all made by the students. We just give them this base plate, like the plastic part, the components. If they did everything, they did the screwing, they did the wiring, everything was done by students. Okay, and yeah, it was a very challenging objective, honestly, especially considering the level of expertise most students have, since we're not really used to working with this kind of stuff. But yeah, I'd say a lot of them, considering the fact they did very well, honestly. And yeah, so we can start. Was how should we approach this problem, which is the line following for those who just came in. So first step is figuring out the connection. This was a very hard thing for a lot of people. Again, not that many people dealt with wiring stuff or this kind of things, and it was a lot of wire, a lot of components to wire. Power, sometimes some stuff can burn out, sometimes stuff can malfunction. But yeah, for wiring, the first thing you need to do when dealing with something like this is, so right here we're dealing with something called Arduino Nano. For those of you who don't know what an Arduino is, it's a microcontroller. So basically it's the brain of a robot. It controls all of your inputs and outputs. It controls everything in the robot. It's what you put your programs on. It's what you're programming. So right here we have what's called a pinout for the Arduino Nano. This pinout tells you, it's a diagram of the Arduino itself. It tells you what each pin in the Arduino, what it does, what you need it, what you can use it for, and those kind of things. So let's say, for example, I'm connecting something. Oh yeah, here. So let's say, for example, I'm connecting something like a motor driver. I want to power the robot and make it move. So for motor drivers, you need what's called the Pwm signal. For those of you who don't know what the Pwm signal is, it stands for pulse width modulation. It's a way to output analog signals using digital input. You don't need to get into that. What you need to do, oh yeah, sure.
So essentially you can control the electronics through the pins, right?
Yes, you can control the electronics through the pins. Everything is done using programming. It uses a form of C. It's like Arduino C. But yeah, so like PWM. Basically what you need to do from PWM, you're emulating an analog input. So we all know digital is either 0 or 1. But for a motor, you need to control how it moves, at what speed it moves. So you need a range of input. So the way we do that is by using what's called PWM. So you basically either you're sending an on and off signal like during a short time, so it approximates to like a signal in the middle basically. You don't need to know that, this is just for your information. What you need to know for this kind of stuff is, okay, I need to control, like the motor driver is controlled using PWM. So I need to connect it to PWM pins. So these are PWM pins, the one that has the pink on it. So, okay, let's figure out, I need 4 pins for the motor driver. You can look it up you can look up the motor driver, you can write the code, you can write it on the internet and it tells you how to connect it and everything. But you need 4 pins for the motor driver, 4 PWM pins. So plan it out, basically. So okay, I need 4 PWM pins, so I have these pins and these pins. Okay, I'm gonna use these 2 for the left motor, these 2 for the right motor. Okay, what else am I connecting here? I'm connecting a color sensor. I'm connecting a line following sensor. The line following and the color sensor, they only use normal digital pins. So I can connect it to any of those pins that are called D, like these pins. So basically try to plan it out first before starting to connect randomly, because it makes your life way easier. So plan it out and then, yeah.
How do you know which pins to connect where? So for example, for the motor, you have to plug it into this pin.
So again, the pinout. The pinout is like the amount of time I use the pinout is like, it has to be there. When I'm connecting anything, it has to be there. So like, okay, you can see this is the Arduino Nano. This is the Nano. You can see here is the USB port. Okay, so starting from here, this is pin 1, pin 2, pin 3. You can count the pins. Okay, pin 2 is the PWM pin. I'm gonna wire pin 2 to the forward of the left motor. Pin 3 is gonna be the backward of the left motor, and so that, like stuff like that. And very important, when you're wiring, when you're planning your wirings, note which wires are connected to which pins. So I'm connecting the motors we set to these 2 pins, D11 and D10. Okay, I'm gonna note in a notepad or in my lab or in my program, even easier. You can define it. You can define basically motor A pin, like you can find it as 10 in the program itself, so that like when you're using it during your programming, you can just write motor A forward or motor A underscore F, for example, and you know that this is the pin for the motor. You don't have to hassle yourself with it. And yeah, so like note your pin, note which pin is connected to which component, and as I said, add them to the code as like defines. So it makes it easier and way easier for you when you're trying to program. Because when you're trying to program, try to make your only focus, like don't hustle yourself with like the other stuff. Just make it only about trying to find the correct code, the correct algorithm for the stuff you're trying to do. Anybody has any questions about this part? Okay. So we connected the pins, everything hardware-wise. We're sure that it's in the right place. We can then go to programming the sensors. So now we need to turn on the Arduino. Hold on 1 second. Keep going. So you can connect it to your computer, but here's the thing. Right now we're using batteries, which you should also connect to the Arduino. But when you connect it to the PC, remove the battery pin. So this is the pin for the positive battery, or just remove the battery, because it might overload the driver, it might burn out, something like that. So you have to make sure like you do stuff properly, or stuff will burn out. Okay? And also for the batteries, like these are the batteries we're going to be using. It's called the 18650. A lot of people had problems with these batteries because it's not clearly labeled where is the negative and where is the positive. So for these batteries, you can see here. Oh wait, hold on. Let me set up for the stream so that the stream can see. So these batteries, you can see here, it has like a blank side basically. You can say where like there is more metal showing, and there are side where the metal is not that showing, like there's not that much metal showing. Basically, you can put it down. No. So you can see here, the batteries have these pins, like this one where there is not that much metal showing, the coating is up there, and then the pin with more metal showing. So for those guys, you're gonna have to, the one with the more metal is the negative side. So this one you connect to the spring side. The other one you connect to the side without the spring, basically. So be very careful with that, because inshallah we're gonna have 3 work days. We're gonna talk about it at the end, where you guys gonna have to, you guys gonna experiment with this kind of stuff. You will work with it. You will familiarize yourself with it. You can do whatever you want in a stress-free environment. It's not gonna be a contest or anything. You're just doing the stuff for you to familiarize yourself with it. But yeah, back to our topic, programming the sensors. So here we come to an important part of, so we need to follow a line. This is the robot right here.
Will save the camera like that, or?
Oh yeah, actually I have a better idea. Hold on 1 second.
By the way, if we're gonna talk about, I usually hear about people that have senior projects of like self-driving based RC and stuff. Do they do similar stuff like that, or is it using different equipment, different techniques?
Wait, what do you mean?
For the people that do senior projects that involve RC self-driving, are these the same setups that they use, or?
Well, definitely not. I hope not. Well,
like this is more.
This is more a bit more advanced. This is a bit more advanced. Sorry. The stuff they have is a bit more advanced. So, but it's like basically it's the same idea. Why is this is still like that? Sorry, technical problems. But yeah, it's a bit more advanced. The stuff they do is a bit more advanced, but it's like sort of similar concept where you have a certain type of outputs, and you're taking a certain type of input and taking these inputs and doing an output from it basically. Oh, what's happening here? definitely not that. Very sorry about this. Anyways, hold on. Where is... Anyways, but this is not working for some reason. Window frosting projector. Oh yeah, here it is. Actually, yeah. Sorry about that. Back to what we're doing. So we have here. This is our setup. So we have a line. Let's do it with the actual line we built here. So this is just a bit of a mini track we have. So the robot is supposed to basically follow the line. If you look at our robot here, we have two sensors at the bottom. So we have these two sensors at the bottom. This one, it's called the line following sensor. It either outputs a 0 or a 1, depending on whether it is a line or not. Okay. And right here we have a color sensor that we needed to read the color at the very beginning. Now, I don't know about you, but it's very difficult to do line following using only one sensor. A lot of those who were in the contest felt that. It's very hard to do. So, what can we do here? Anybody has any ideas? That's what a lot of people actually resulted to doing. It's not really ideal, was it?
Use the color sensor as a
And that was the answer that not many people came up with in the contest now that day. So the color sensor can read color, but it can also read black. And the thing that you can do then is have it so that the color sensor acts as another line following sensor. So when you have two line following sensors, it's very easy to do line following. Now the color sensor is not an ideal line following sensor. It's not that easy to, like, you need calibration for it. It's not as reactive as the color sensor, like it's not as fast, but it works for our purposes. So what we can do is use this color sensor as a line following sensor. But for that we need to deal with this color sensor. So how can we deal with this color sensor? I don't know. I don't know anything about it. I don't know how it's programmed. I don't know how it works. There is just pins there. How do I learn about it? So it's very easy. You just go on the internet and find the name of the sensor. So this sensor is called the DCS 3200, if I remember correctly. Hold on. DCS 3200. So you can just search on about it, and you're gonna find many resources. Many of them by Arduino itself. Like they have a lot of resources on how to use different color sensors, different sensors in general, different input